You type, "What's the weather in Penge?" and AI answers instantly. But it never saw the word Penge. Not once. Before AI can read, it chops your words into pieces. This is tokenization, and it decides what AI costs, what it remembers, and why it's bad at spelling strawberry. AI Fundamentals, Episode 1, Tokenization. Who uses tokenization? Everyone touching AI. You use it every prompt. You never see it. Developers training an LLM, large language model, use it to design how the model reads. Their choices here last for years. Companies like Meta and OpenAI use it because tokens make money. You're billed per token, and it affects you when AI cuts off mid-sentence or forgets. That's a token limit. If you prompt, build, or pay for AI, you're already in the token business. What is tokenization? Simple. Turning text into numbers AI can use. Computers hate letters. They love numbers. So a tokenizer breaks text into chunks called tokens, then assigns each a number. A token isn't always a word. Cat is one token. Unbelievable is un. Believe, able, 3 tokens. Is one token. Even is a token. Think Lego. Your sentence is a castle. AI can only hold bricks, so we break the castle first. Different models have different brick sets. Same sentence. 5 tokens in GPT-4, 8 tokens in Llama. That difference matters. When does it happen? At the start and at the end. Step 1, you type. Step 2, tokenization. Words become token numbers. Step 3, the model. Pure math on numbers. Predict next token. Again. Step 4, detokenization. Numbers back to text. Step 5, you read. So tokens are the front door and back door. Nothing passes without them. Hit a context limit. The bouncer stopped giving out tokens. Reply ends. Where does tokenization run? 2 places. 1, your device. Small models in WhatsApp or Meta AI can tokenize locally. Faster, private. 2, the cloud. Big models tokenize in data centers. Your prompt travels, gets chopped, computed, returned. You can watch it happen. OpenAI and Llama have tokenizer demos online. Type Penge and see. PenGE. 2 tokens? The model doesn't know it's a town in London. It just sees 2 bricks. Why does that matter? Because tokenization controls cost, memory, and capability. First, cost. AI systems charge per token. Fewer words can save money. 1,000 words might become 700 tokens or 1,500. The way you write changes the price. Second, memory. Context. Windows are measured in tokens. 8,000 tokens does not mean 8,000 words. Dense text fills memory faster. That's why the AI forgets the start of long chats. 3. Capability. Tokenization decides what AI sucks at. Math? 12, 3, 4, 5 might be 1 token. The model can't see 1, 2, 3, 4, 5. It's like doing calculus with emojis. Spelling? Strawberry is straw, plus berry. It doesn't see 10 letters. Languages. English gets efficient tokens. Hindi, Thai, Arabic often get shattered into tiny pieces. More tokens, more cost, worse results. So when AI is weird, don't say it's dumb. Say it's looking at Lego. How does it work? Most models use byte pair encoding, or BPE. Every letter is a token. The word hello is split into 5 pieces. HELLO, 5 separate tokens. Then the model scans millions of books looking for common pairs. Maybe it sees E and L together constantly. So it merges them. Now EL becomes 1 token called EL. After merging, hello becomes 4 pieces. H, EL, L, O, 4 tokens instead of 5. Repeat that process 50,000 times, and you build a 50,000 token vocabulary. Some tokens become full words like "the." Some become partial pieces like "ing." Some are whole words like "the." Some are pieces like "ing." Some are odd like "app" from Apple and application. Now, when you type, the tokenizer plays Tetris. It grabs the biggest token it knows, lays it down, and keeps going. The word penge gets processed. Pen drops first, then G. Click, click. Why not use full words? Too many. Names, typos, new slang. You would need millions of tokens. 50K smart pieces can build anything, even penge. Penge. Done. So, to recap, you type text. Developers turn it into number bricks. AI companies process those bricks. Text to numbers is the first step, and the last step turns numbers back into text. Your phone sends the request. The cloud does the thinking. Why? Cost, memory, capability. The model scans huge amounts of text, finds common patterns, and merges them into roughly 50,000 reusable pieces. But now comes the important part. We've built the bricks. So how does AI know king and queen are related? How does it know Penge belongs near London? Next up, embeddings. Tokens become coordinates in space. Words with similar meanings get placed close together. King sits near queen. London sits near Penge. AI stops seeing words as text and starts seeing relationships. That's how models understand similarity. Search, recommendations, and meaning itself. We'll build that system in episode 2. Comment your town below. I'll reply with its token count. Subscribe for episode 2.